Today we'll learn how to configure a static route on a switch. First, let's learn about the application scenario. Static routes are manually configured by administrators. This type of route is easy to configure and control, so it's widely used in small and medium enterprise networks. As shown in the figure on the right, PC1 and PC2 need to communicate through the two intermediate layer 2 switches using static routes. Second, check out the configuration roadmap. The configuration roadmap involves two steps. Step 1, configure a static route from switch A to PC2. Step 2, configure a static route from switch B to PC1. The second static route is also called the return route. Now that the configuration roadmap has been completed, let's go over the configuration procedure. The first thing to do is to configure a VLAN and an IP address for each interface. Here, switch A is used as an example. You can use the following commands to accomplish this step. After the first step has been performed, you can see that the switch A routing table contains only direct routes. If PC1 pings PC2, how will packets between the two PCs be forwarded? The answer is that PC1 will send a packet with destination address 172.16.2.1 PC2's to its default gateway switch A. When switch A receives the packet, switch A cannot find any routing entry destined for 172.16.2.1 because no entry in the routing table matches the destination address. Subsequently, switch A discards the packet. So far, PC1 and PC2 have not communicated with each other. To solve this problem, you need to ensure that switch A can correctly forward this packet. In other words, ensure that the switch A routing table contains a routing entry that matches the destination address 172.16.2.1. You need to configure a static route on switch A to guide data forwarding. The static route is easy to configure as it requires just one command: IP route static. After the static route has been configured, the switch A routing table contains a new routing entry with destination network segment 172.16.2.0 and a hop at 172.16.100.2. When switch A receives a packet with destination address 172.16.2.1, switch A searches its routing table for a route based on the destination address, finds a matching route, and then sends the packet to the next hop of the route, which is 172.16.100.2. Consequently, the packet is transmitted to switch B. After receiving the packet, switch B searches its routing table for a route based on the destination address IP 172.16.2.1, finds a matching direct route, and then sends the packet to PC2. Finally, PC2 receives the packet. After the preceding operations have been completed, can PC1 and 2 communicate with each other? Not yet. This is because data communication between two nodes is bidirectional, and currently only a static route from switch A to PC2 is available, but no return route from switch B to PC1 is available. The static route from switch A to PC2 only ensures that packets from PC1 to 2 can be forwarded to PC2. If PC2 needs to send a packet to PC1, PC2 will send the packet with destination address 172.16.1.1 to its default gateway, switch B. Switch B receives the packet and then searches its routing table for a route based on the destination address. However, switch B does not find any route matching destination address 172.16.1.1 and so discards the packet. To ensure that PC1 and 2 can communicate with each other, you still need to configure a static route with destination address 172.16.1.0 to 24 and next hop 172.16.100.1 on switch B. After the static route has been configured, PC1 and PC2 can communicate with each other. In conclusion, to ensure that the two communicating parties can communicate well with each other, you need to configure static routes on the incoming and outgoing paths. You can also use the IP route static command on switch B to configure a static route with destination address 172.16.1.0, 24-bit mask, and next hop 172.16.100.1. The following describes how to configure a static routes on devices. Firstly, configure a static route with destination address 172.16.2.0, 24-bit mask, and next hop 172.16.100.2 on switch A. After the static route has been configured, check the switch A routing table. You can see that a static route with destination network 172.16.2.0 to 24 and next hop 172.16.100.2 appears in the switch A routing table. This static route can guide data forwarding on switch A. Secondly, configure a return route from switch B to PC1. Configure a static route with destination address 172.16.1.0, 24-bit mask, and next hop 172.16.100.1 on switch B. After the static route has been configured, check the switch B routing table. You can see that a static route with the destination address and next hop appear on the switch B routing table. Now, incoming and outgoing paths are reachable, ensuring that PC1 and PC2 can communicate with each other. After a static route has been configured, is there any way to identify the static route? Of course there is. You can configure a static route description. A static route description identifies the purpose and direction of the route, facilitating network management. You can add a description keyword in the static route configuration command. Try to configure a static route description on a device. Assume that we have a static route with destination address 172.16.2.0, 24-bit mask, and next hop 172.16.100.2. It goes from A to B. In the static route configuration command, you may input description A to B. Then you will see the A to B description has been given to the static route. This is a typical way to describe a static route. Well, that's about it. Thanks for listening. To obtain more information about common configurations and typical features of Huawei switches, see the All About Switches threads. Where do you find these threads? Using Google search, type in All About Switches site Huawei.com in the search field and click any of the displayed links to enter the Huawei Enterprise Support community. For details about more features, visit the homepage. The All About Switches threads describes typical configurations and users' questions about Huawei switches. Well, that's all for today. Thanks for listening, and goodbye.